Hello everyone, my name is Federico Zanetello, and I am an iOS developer living and working here in Thailand. Today's topic is Swift scripting, and you might be wondering, we are at UIKonf, why would we talk about Swift scripting? And yeah, I understand, fair question. There are many different reasons, and one of them is actually we as developers use scripting all the time, use things like fastlane, swiftLint, xcode, sorceries, you name it. And while those tools are amazing, the project need is for automation doesn't end there. There is always something else in our own project that we can automate to make our process smoother. And why Swift scripting? Well, the main reason is familiarity because we are all iOS developers, so it means that we all know how to write Swift. And so also another reason is because let's say that we are on a team, and if we write the script in Swift, the chances are that also the rest of the team will be able to read it, understand it, and maintain it, even if we move to another team or somewhere else. So time to get started. But first things first, let me introduce to you the script that we're going to build today, which is hello. And the main function of this script is to greet you. And I know it sounds very simple, but we will see many different ways on how to build this today. So let's have a look at that. But first, we need to create the script. And the way we do this is through the Swift Package Manager. And we're going to create a new Swift package, not of type library, but of type executable. So the way we build these kind of packages are thanks to the terminal. So you will just follow the three commands that you see here on the screen, and we're going to create a folder, jump in that folder, and create this executable. We need to use the terminal in this case because if you use an Xcode to create a new package, it will default to create a package library, which is not exactly what we want in this case. So let's use the terminal for this. And once we do this, we have all our package structure already there in the folder. And in case you already are familiar with libraries, Swift package libraries, this is nothing new. But let's say, just to be sure that everybody's in the same page, let's have a rundown on how this works. So from bottom to top, we have, first of all, the test folder, which will contain all our test targets. Then we have a source folder, which will contain all our build targets. And as you can see, the command already creates two targets for us. We have a hello, a build target, and a hello test target. So targets, when we talk about targets in Swift packages, are kind of like folders where everything that is declared within that folder is available. All the declarations are available to every other file within that folder. And so after this, after all the targets, we also have another file that is very important, which is the package.SWIFT file. This is the package manifest. So let's have a look at that next. So this is basically the configuration of the whole package, and is always the first thing that I look at when I look at a new package library on GitHub, for example. And in here we find things like the package name, its dependencies, and also the declaration of all the targets. So again, the command already created two targets for us, and here we see again those two targets. We have the build target hello, and then the hello test test target. Again, you can create all the targets that you want as a folder, but if you don't add them in this file here, they simply don't exist. They simply will not even be built. So it's very, very important to always have the package.SWIFT file up to date with all our project structure. Talking about the project structure, I want to highlight one more file, which is where we're going to spend the rest of the talk today, which is the main.swift file. This is the file that we are going to execute when we launch our executable. And the way it works is similar to Playgrounds, where we run things from top to bottom, and the script will terminate as soon as we reach the end of that file. So let's have a look at what's in there. And as you can see, the whole content of this file is just one line, and it's a print statement saying hello world, which is awesome because this is exactly what we want our hello script to do. So we have nothing else to do here. It's done. So time to build and run this. Oh, and how do we do this? Well, in Swift packages, we have mainly two ways. And in this case, I'm showing you the terminal way, which is from the root of our package, we can launch Swift build, Swift run, and Swift test. But another way to do this is with Xcode 11, we can just use Xcode. So we can open a package as if it was any other project that we usually open in Xcode, and then we can use the user interface to build, run, and test our package from there as well. And now we're done. Congratulations. Now you know exactly how Swift executable work. You know how to build them, how to run them. And so you can consider yourself as a Swift scripting developer as well now. Okay, yes, true, but there is still something else that we need to cover first, which is actually a big difference between apps and scripts, and which is the user interface. Because when we talk about apps, we have a GUI, we have a graphic user interface. But when we talk about scripts, we have a TUI, a text user interface, which means that the way that the user interacts with the script and the way that that flows is kind of different. And so let's cover some of those differences now. An example is launch arguments. So a way for the script to get input from the user is when the user launch or command, beside the name of the command, we'll also pass other inputs from there. And the way we get a hold of those information from our main.swift file is thanks to the command line object. So the command line object, as the name says, it represents a command line. And one of the properties that are available for us is the arguments property, which is an array of all the arguments that are passed to this script at launch. And as you can see, the first thing that I do is always remove the first argument of this array, because this array always contains the execution path as the first element. So in this case, we are not interested in that one, but we're interested in what's next after that. So that's why I'm removing it. And then for this script, what I want to do with this argument that is passed to the script is just to greet back the user. So I look if in this new array, I get a name. If there is one, then I print it out. Otherwise, I call this exit with an exit failure. So in scripting, sometimes we want to terminate our script before the execution ends, complete the whole main.swift file. And a way to do this is by calling exit and then pass exit state. The exit state is quite important because, for example, is what we use on the build phases of our of Xcode in our projects to terminate the build process in case some of the script fail. And as you notice, in this script, I don't have an exit success because that is automatically called for us when the main.swift file is entirely consumed. So in case we don't go to the exit path, so in the other case of the printing, then our script will terminate because nothing else is in there, and it will automatically call exit with a success state. So we don't have to write it everywhere. Cool. And here on the right, you see an example where I'm launching the script with my name, and then the script will greet me back by saying hello and then Federico. So awesome. Now we're seeing how we can interact with inputs that are passed when we launch the script, but sometimes our script needs more inputs from the user after the script has been launched. And in that case, we need to make our script interactive. So when we talk about interactivity with our scripts, it means that at some point during the execution, we need to pass the command back to the terminal where the user is able to input more things. And then after the user hit the return key, the execution can continue. And the way we do this in Swift scripting is thanks to the red line command. So this line here, first of all, is synchronous, which means that the execution of the script will stop when we reach this line and we hand the control back to the terminal. And after the user hit the return key, this red line command will also return a string containing whatever the user has input in the terminal. So after we got this information, this string, we can do whatever we want with it. In this case, I'm looking just if it's empty or not. And if it's empty, I exit again with a failure state. Otherwise, I print whatever it was called, whatever it was passed back from the terminal in the terminal again with a hello at the beginning. Another important aspect of scripts is environment variables. We use environment variables, especially when we work on the CI, to share secrets with our repositories. And we can also use Swift scripting with environment variables quite easily because we need to use an object called process.info. And this process.info object, as the name says, contains a lot of information about our process, about our script. And one of the information that are available for us from this object is the environment. And the environment is just a dictionary containing all the keys and all the values of all the environment variables. And once we have a hold of this dictionary, we can just query for whatever key we need. And if there is something, then we can do something with it. And in this example here, I'm declaring this my name environment variable. And when we launch the script, I'm going to check if this variable is set. And if it is, then I will start to print to the user the greeting. Otherwise, again, I will just exit with a failure state. And here on the right, you can see an example on how to do this. So by declaring my name equal Federico, I'm setting this environment variable on the environment, and then I just run the script again, and then our script will just fetch this value and print it out to the screen with a greeting. Cool. Another important aspect of scripting is pipeline messages. So the concept of pipelines in scripts is basically when we have a chain of command where the output of the first command is going to be the input of the second command, and the output of the second command will be the input of the third command, etc., etc. And we can support this in Swift scripting as well, because all we have to do is have an instance of file handle, which is a type that, as the name say, handle things like files, sockets, pipes, and other. And once we have this instance, in this case, we're going to have the instance from standard input, we can check for the available data, which is anything that has been passed to the script. And with this data, we can do whatever we want. In this case, what I'm doing is I'm turning this data into a string, and if successful, I will just greet the user with whatever was in this data. Otherwise, exit failure. You see here on the right an example where I'm using the printf command, and this will just, I'm pipelining this to our script, and then our script will read what was in the pipeline and then print back in the terminal the name of whatever was passed. Cool. So now we covered the basics. Now we can go ahead and start writing our scripts. And after we write 1, 2, 3, 4 commands, we will notice that actually there is a lot of time that we are working mostly on things that are around the script itself, but not on the core logic. And an example of this is argument parsing, because we already seen how to do this today, but that was a very simple example. But usually our scripts will be able to handle much more data, much more inputs. And also this means also, for example, flags and other kind of inputs that the user can pass to the script. And having to parse this by yourself takes quite a lot of time, and it's also very error prone because, for example, for flags, we have different ways in which those flags can be ordered, and we need to support all of them. And then we also have different kind of inputs, etc., etc. So wouldn't it be great if there was a way to have all of this parsing already sorted out by somebody else, and then we can only focus on the main logic of our script? Of course, the answer is yes. And this is why I'm talking to you about this new library called ARGUMENTPARSER now. So ARGUMENTPARSER is a new library from the Swift team that has been launched very recently. And before getting started with it, I want to say this is a new library, so it's time to add a new dependency in our package. And how do we do this? Well, we have to go back to the manifest file, and in there, we need to declare, first of all, a package dependency, which is the first highlight that you see in this screen, where we have to pass the URL of the package repository, and then from which version we want to support. And then in the target where we want to use this library, we need to add in there which product of this package we want to use. In this case, it's just ARGUMENTPARSER. And once we do this library is going to be available in our main.swift file. So let's have a look at that next. And again, our script only requires one input from the user, and we are going to print it out as with a greeting on the terminal output. And with ARGUMENTPARSER, the way we do this is by, first of all, declaring a struct, which kind of reflects the whole command that we're going to build. And so we declare the struct with the name of type, then the same name of the script. And then we also tell of this struct to be to conform to a parsable command protocol. We don't need to worry about what this parsable command declare, because everything is already taken care of by ARGUMENTPARSER. The next thing that we need to do is declare as a property of this struct every single kind of input that we expect from the user. And so in this case, I'm declaring a new property called name of type string, which is exactly what we want from the user. And not only that, but you also need to associate every single property to a property wrapper declared within argument parser. There are only 4 argument property wrappers defined in argument parser, and one of them is argument. But let's say that, for example, we want to have also support for flags. We would declare a new property with add flag instead. Cool. So after we declare all or kind of inputs that we support, all we need to worry about is filling the run method. The run method will execute only after all the parsing and all the validation of all the inputs has already been done. So when we reach this state, it means that all our arguments are already there for us. We don't need to worry about checking for a viability of them, optional, etc., etc. It's already all everything done. And so in here, we just need to focus on what our script, our logic is. And after this, as you can see, we write a bit of code here on the left, but if we look at the right, we see different things that we have thanks to this new library. So first of all, the happy path, as you can see, is exactly as before. So we run the script by passing an argument, and then the script will greet us back. That's done and is exactly like before. But let's say that, for example, the user forgets to pass the input. At that point, previously, all the script will do is just quit immediately without printing anything to the terminal. But now, thanks to argument parser, we have a human readable error printed out to the user. So in this case, it's saying error missing executable argument and then the name of the argument that is missing. And then it also prints to the user a reminder of how to use this script. So in this case, it's just hello and then the argument. But if our script was more complicated, in here we will see again all the possible arguments that we need to pass. But not only that, but thanks to the argument parser, we also get a help. So just imagine if I have to write my own help for my own script and you have to write your own help for your own script. First of all, they will look totally different. But then just imagine that we need to maintain that help because our script keep evolving. We have new inputs. We remove all our inputs. Some other inputs maybe they are different now than before. We need to update constantly all our help as well. But now, thanks to argument parser and some magic behind the scenes, we get all of the help structure for us for free. So first of all our script will look exactly the same. All our script help will look exactly all the same. So it's very standardized. And then we don't need to worry about maintaining this help because we get it for free just by declaring this struct in our main.swift file. And yeah, that's it. This library is very sweet. It's very nice. And if you have any opportunity, please also have a look at the implementation because actually, the implementation is also very, very good. But this is enough for argument parser. And really, there are a lot of libraries out there that we can use. And I want to give one more example today, which is TC utility and TC basic. So those two libraries are actually part of the Swift tool support. That's why they have the prefix TCC, which is tool support core. And this package is actually what is being used within the Swift package manager itself. So it's a part of the Swift package manager. But because everything around the Swift package manager is open source, it means that this package is also viable for us to use in our own tools. And well, in this library, there is a lot of things. But before digging into that, let's add a new dependency in our package. So as you can see here on the screen, we need to update the URL of our package in our package dependencies, and then we need to update the product in our target with the new library. But once we do this, we will get those two libraries available for us in our main.swift file. And there are many things that we can do with these libraries. But today I want to show you one example, which is the progress state. Because we as iOS developers know that first of all, we don't want to freeze our UI when we are doing some background work. But not only that, but we also want to show to the user that something is happening behind the scenes, and soon the result will be shown to the screen. And the same thing is true also for scripting, because we don't want to have the screen completely blank when our script is doing something on the background, but we want to tell the user, hey, we are doing something, and soon you will get the result on the screen. And a very nice way to do this is thanks to those two libraries, where we have an animation called %progress animation, where we also can pass an optional header. And after we have this instance, every time we have a new update, we can tell the user by firing a new update on this instance by passing the number of steps we are at out of how many steps, and then pass also an optional text. In this case, for this example, I'm just printing the same text all the time. But in your own script, you can take advantage of this text to tell the user exactly what's happening behind the scene. So in here, we can say something like, I'm fetching this, I'm unzipping that, I'm building that, etc., etc. So please take advantage of this, because this way we are even more transparent to the user and they know better what's going on behind the scenes. And lastly, we need to call complete or clear on the animation. And the difference is that if we call clear, the animation, the whole progress bar will completely disappear from the screen, from the terminal, and then we can continue our script without, as if that animation was not ever shown. Cool. We have built all our scripts. We are using amazing libraries to make the experience for us and for the user better. It's time to release our script. And by release, this what it means is just have the script available everywhere in our machine, because so far we always have to run it from our package root by saying swift build, swift run, and then the name of the target, which is great for development, but we also want to be able to use that script everywhere. So how do we do this? Well, it only takes two commands. The first one is building our script in the release configuration. And what this will do is we'll create a new executable in a hidden folder in our package root that is .build/release/ the name of the script. And once we have this executable, we need to copy it in a place that is going to be looked at from the terminal whenever we type a new command in the terminal itself. And for Macs, for example, a folder where this happens is root user local bin, and then in there we put anything we want. And once we have the executable in there, we can just firing it by calling the name of the executable, and we are done. Whew, awesome. So congratulations. Now you really know how to write scripts. You have already seen the basics and even more. And with this, please go ahead and write many scripts, and please share them on GitHub so everybody will look at them as well. With this, I want to show you a few links. The first three links are around the Apple and the Swift Package Manager. Without those, of course, I would not be able, this talk was not going to be possible at all. Then we have a blog where if you want to see this talk in a blog form, you can look at that fivestars.blog article. And lastly, if you want to see these slides, look at the source code and copy and paste the source code. I'm going to upload these slides very soon in this talks repository. With this, I want to thank the organizers for this amazing opportunity. This is real fun. And thank you all for listening. And I hope you enjoy the rest of the conference. Bye.